Today we are going to discuss the topic about losses of three-phase induction motor. There are three losses in three-phase induction motor. One is magnetic losses and another one is mechanical losses and last one is electrical losses. These losses due to constant or fixed losses or variable losses. First one is magnetic losses. First one is constant losses or fixed losses. Constant losses are those losses which are considered to remain constant over normal working range of induction motor. The fixed losses can be easily obtained by performing no load test of three-phase induction motor. These losses further classified into iron loss or core loss, mechanical loss or frictional losses. Iron or core losses. Magnetic losses are also called as core losses or iron losses. These losses occurs in the stator core and rotor core because of the rotating magnetic field. There are two types of core losses. One is eddy current losses and another one is hysteresis losses. The hysteresis losses occurs due to alternate changes in the magnetic field in the stator core. These losses are minimized by using the select the high rate silicon steel of the material of stator and rotor. The eddy current losses are due to flow in eddy current through the body of the stator core. These losses core minimized to the laminated construction of stator core. These two losses depend upon supply frequency. And another one is mechanical losses. The mechanical losses consist of frictional losses and windage losses. Induction motor speed drop is very small, so that mechanical losses are part of the constant losses. Constant losses is equal to iron losses plus mechanical losses. These losses are zero. Started with increased speed, these losses increases. Three-phase induction motor speed usually remains constant. Hence, these losses almost remains constant. Variable losses. These losses also called copper losses. These losses occur due to current flowing to the stator and rotor winding. As load changes, current flowing the rotor and stator winding also changes. Hence, these losses also changes. Therefore, these losses called variable losses or copper losses. Performing block rotor test on three-phase induction motor. This is the power transfer and stage of three-phase induction motor. First one is active power in stator. At the time it will produce stator copper losses and stator iron losses. Active power supplied to the rotor at the time produced rotor copper losses. And electrical power is converted into mechanical power at the time produced rotor copper losses. It will connected to the shaft at the time produced windage and friction losses. Induction motor converts electrical power supplied to the mechanical power. The various stages this conversion is called power transfer stage of induction motor. The three-phase power input to induction motor, that is stator input. Power input is equal to root 3 VL IL cos pi. VL is a line current and VL is a line voltage and IL is a line current and cos pi is a power factor. Efficiency of induction motor. The ratio of net power available at the shaft and net electrical input of the motor is called overall efficiency. The efficiency is equal to output power divided by input power multiplied with 100. This is the efficiency of induction motor curve. The x-axis of output power and y-axis of efficiency. The curve gradually increased. Thank you.